In this video, we'll be focusing on the concept of calculating the probability of compound events. In order to understand the probability of compound events, we first need to revisit the concept of how to understand a Venn diagram. This is probably something that you have seen at some point, but my guess is for most of you, it's been a while since you have used Venn diagrams. So let me give you a quick refresher on Venn diagrams. In Venn diagrams, there's basically two types of symbols that you need to understand, and we'll talk about these in a second. But when you see a U like this, what we're referring to is the union of two different things. And when you see that U basically upside down, so that it looks like an arch, this symbol refers to the intersection. You'll see time and time again in this section of the book, those symbols come up, and it's important that you know how to use them correctly. So let's take a look at a Venn diagram. Let's say that in this circle represents all of the women in the world. I'm going to draw another circle that represents all of the people in the world who are millionaires. So to represent that, I'm just going to put a money sign. Now, there are certainly women in the world who are not millionaires, and all of those people would lie in this area of the Venn diagram. There are also certainly people in the world that are millionaires but are not women. Men that are millionaires, they would lie in this section of the Venn diagram. Where the two circles intersect, which is the intersection of two different sets, would be where people are both women and are millionaires, and those people would lie here where the two circles intersect. It's important to note, and this will come up later, that there are sets that don't intersect at all. If two sets do not intersect, we say that the sets are disjoint. Or you can think of that, you can see in that word, not joined together. So if two sets are disjoint, they have no intersection. Their intersection is zero. That'll become more important here in a second. So when we're looking at a couple of different events, and we're looking at the union of those two events, when we're talking about a union, we're talking about, for example here, this says the probability of A union B. Union of two events would mean either that A happens, or B happens, or both of them happen. In terms of a Venn diagram, it would be like thinking either they're women, or they're millionaires, or they're women who are also millionaires. And when you're calculating the probability of compound events, we do it using the following. We take the probability of our event A, and we add that to the probability of our event B, and then we subtract out the probability of the intersection of those two events. The reason behind why we do that is if you think about calculating the probability that a person is a woman, and then the probability that a person is a millionaire, in both of those calculations, you have counted all of these people in the middle, in the intersection. So in a way, you've double counted those people, and in order to account for the fact that you've double counted those, we are going to subtract out the probability that someone is in the intersection of those two things. Let's try to make this a little bit more specific by way of looking at an example. And I think that based on this example, you'll be able to understand the concepts a lot more. Okay? This is similar to one of the examples found in the book, but see if you can follow along with this. I have here drawn a spinner. So think that I'm going to spin this arrow and it's going to land on one of these colors. I've described the probability that the spinner lands on each of the four different colors here. The probability of orange is 1/2, yellow and blue are both 1/8, and the probability of landing on red is 1/4. Then I've described three different possible events over here, and I've named those events E, T, and M. Event E is that you spin a primary color. The spinner lands on a primary color that is red, blue, or yellow. Event T is that you spin a color with 6 letters in its name. And event M is that you spin an orange. Now, in the last video, you learned how to calculate the probability of any one of these events happening. So if I just ask you to calculate the probability of spinning an orange, that would be pretty easy because that's already listed. It's 1/2. What we want to discuss in this video is what if it's a compound event? What about the probability of E union T? That is the probability that E occurs or T occurs or both of them occur. How do we calculate that? It's always a good first step when calculating these compound probabilities just to directly apply this definition. So instead of using A and B as over here, I'm going to apply this definition, but I'm going to use my specific events, which are E and T. So according to my definition, this is equal to the probability of E plus the probability of T. I'm running out of space here, minus the probability of E intersect T. At that point, all I've done is apply the definition. Now, from here, what I need to do is actually figure out what those probabilities are, and you're going to find that it's not too difficult. So the probability that E occurs is the probability that we spin a primary color. Well, spinning a primary color can happen if we get a red, a blue, or a yellow. From the text, hopefully you would know that in order to find the probability of all those together, we would add up those probabilities. So the probability of E is 1/4 plus 1/8 plus 1/8, which turns out to be 1/2. The probability of T, spinning a color with 6 letters in its name, we're going to have to look and see which of our colors have 6 letters in its name. In this case, orange does and yellow does as well. So we would add 1/2 and 1/8, and if we did that, we would come up with 5/8. Now for the part that's the trickiest part of the problem, we need to subtract out, is there an intersection of these events, E and T? So in other words, is there a color that is E, a primary color, but is also T, a color with 6 letters in its name? In this case, the answer is yes. A color that is a primary color that also has 6 yellows in its name, we only have one that fit that category, and that's yellow. So E intersect T, another way of saying that would be the probability that we get yellow, which is 1/8. So the probability of E intersect T is 1/8. So all we need to do is to add together the probability of E and T and subtract out the intersection. If we do that, we're going to end up with 1/2 plus 5/8 minus 1/8. What is interesting about this problem is when you do that, you actually come up with a probability of 1, which is kind of an interesting probability. The way you understand that in real terms is that it is certain to happen. It is 100% sure that this event will happen. So we need to analyze why that is. So why is it 100% sure that we will either spin a primary color or a color with 6 letters in its name? Well, if you look at the spinner up here, when you spin, there's really only 4 options that you can get, and 3 of those are primary colors, yellow, blue, and red, and the 4th option happens to be a color with 6 letters in its name. So it actually makes sense that our probability would be 1. Notice also that if you forgot the step of subtracting out the intersection, you would have come up with a probability that would have been greater than 1. And as I said in the previous video, any probability that you arrive at that is less than 0 or greater than 1 should immediately set off an alarm for you that you've done something wrong in the problem.